Hi all, so welcome to week 1 lesson 2 for specialist mathematics. This lesson is going to focus on some new ways that you can use to expand polynomial functions. So you're used to FOIL, but we're going to have a look at a couple of other methods that if you are able to master these methods, expanding is going to be a lot easier. So just remember either in your notes or in the discussion board just to check in. So please remember we have a discussion board on eLearn. I'll just get that up now. And courses, discussion board. So no one's accessed discussion board for lesson 1. Let's see if anyone wants to check in for lesson 2. So I'll be on here for the entire period. So this is a lesson starter. I'd like you to have a go at expanding these 3 expressions. So 2x bracket x minus 3. I'll have a go at expanding that, and then to factorize these 3 here. So just pause the video and have a go at doing those. They shouldn't take you particularly long. Okay, so now that you've done that, we'll go to the answers. So just check your answers against these, and if you have any issues, let me know. Okay. So the first method that we are going to be using in order to expand is the box method. Now the box method is something that's been taught more recently, particularly in primary schools and junior high schools, about multiplying, but they work really well when expanding out algebraic expressions. So the advantage of this over FOIL is that FOIL is limited to two sets of 2 terms. So x plus 2 in bracket times x plus 1 in bracket, something like that. And the box method can have basically infinite terms within brackets, but it is still restrained in that it can only have 2 sets of brackets because it's a 2-dimensional table that we have here. So we got x plus 2, so we write x2 here, and then x squared minus 4x minus negative 4x plus 3, 3. And then we just multiply them here. X times x squared is x cubed, x squared times 2 is 2x squared, and etc, etc. And then once we have done that, all we need to do is just add all of these terms together. So these are the resulting terms from expanding in here. And once we add these together, we can come up with the answer, which is x cubed minus 2x squared, take 5x plus 6. So this is a much simpler method than trying to use FOIL for brackets that have more than 2 terms in them. And if we start getting to a point where we've got 3 or 4 terms for each set of brackets, the box method can actually be really good. If polynomials are symmetrical, which means that it's just x plus y squared or x plus y cubed, and that they're all the same, we can actually use Pascal's Triangle. It's a really, really simple way of getting it sorted. So Pascal's Triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, etc. And all we can do here is, say for example, we have a plus b cubed. Okay? Because it's cubed, we go to the 3rd row of Pascal's Triangle, 1, 2, 3, and our a is cubed. Okay? And what we do is we reduce the power of a as we go down. So a cubed, a squared, a to the power of 1, a to the power of 0. And what we do is we increase the power of b as we go from left to right. So b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 3. And because we're using Pascal's triangle, we, on the third row, 1 times a cubed, 3 times a squared b, 3 times ab squared, 1 times b cubed. And so it's really easy to use this. For example, if we had a plus b to the power of 5, this would be what we would get here, down here. It's a really, really simple method, but it only works if the polynomials are symmetrical. This is a bit of revision from last term using the systematic method. It is essentially using the FOIL method for multiple brackets. So this does not need to be symmetrical, okay? But it also doesn't really help us that much. It's a very long-winded method, but this will apply for every situation we have, okay? So a number of combinations is the number of terms in each bracket times the number of brackets, to the power of the number of brackets. Okay, so here we have 2 terms in each bracket to the power of the 2 brackets, so 2 to the power of 2 is 4. So we have 4 different combinations. For a plus b in bracket times c plus d in bracket times e plus f in bracket, we have 2 terms, so t is 2. But we have 3 brackets, so to the power of 3 is 8. And we have 8 combinations. So a plus b in bracket times c plus d in bracket is ac plus ad plus bc plus bd. And this here is ace plus acf plus ade plus adf plus bce plus bcf plus bde plus bdf. Okay, so all we're doing is we're taking the first one, and the first, and the first, then first, last, then first, last, then first, last, then last, first, last, last, first, last. Basically what we did at the end of last term. And also, some people found this helpful last term. Using tree diagrams in order to do the same thing. So these 2 methods are pretty much the same, except they're laid out just a little bit differently. They are the same method, but it's just using a tree diagram to make it easier for you. Okay, so here we've got pretty much the same as before, except d is negative. Okay, so we have first, last, first, last, last, first, last, last, first, last, first, last, first, last, first, last, first, last. Okay, so it's the same process as before. So I got confused there. This does get a little bit complex. It's easier if you are writing it down. Okay, so these are the 4 methods that you can use, and they apply differently. So box method is great if you have 2 terms, 2 sets of brackets. Pascal's triangle is great if you have symmetrical brackets. And then the systematic method and the tree diagram are long-winded and annoying, but they will work for any situation. So the first thing I want you to do is expand this expression using the box method. So pause the video, have a go at this. Okay. And let me know what you got. Secondly, what I want you to do is use Pascal's triangle to find what x plus 3 to the power of 5. Touch base with that in a second. And finally, what I want you to do is choose, you either use the tree diagram or the systematic method to work out what the expanded version of this expression is. Okay, back now. Miss Crane just had a couple of questions. Okay, so 3 activities for you to do. Box method for this one, Pascal's Triangle for this one, and you choose either tree diagram or systematic method for this one. Okay, so have a go at those 3. So 1 attempt for each method, and you should be able to get it sorted. They're relatively simple to use. It's just getting you used to the idea that there are more methods to use than just FOIL, and that should, as we get into some of the more complex stuff, make it easier for you moving forward. All right. So what I'd like you to do is write that essay. And this can be reflective, so this is your own opinion, so feel free to use first person. Which method of expanding do you feel is most powerful? And which method of expanding do you find the most intuitive? So you're choosing from the 4 we've gone over today. And this is purely your own personal opinion. What do you think is most powerful? What do you think is most intuitive? But if you're going to say that, for example, the box method is most intuitive, tell me why you think that. Okay, so this is your own personal opinion. Finally, a reading task. We have a graph here, and what I want you to do is write a sentence explaining what this graph is showing. And the graph is annotated and explains that many koalas have been killed since controls weakened. So what do you think that means? Alright, so please come into the discussion board, ask any questions, let me know if you're having issues with anything, or even just to check in. Okay, I would really appreciate it if you guys came in here and had something to say. And also for those of you who are not in my Year 10 normal maths classes, you are more than welcome to access my other videos. So I'll be doing just normal Year 10 maths videos as well as the specialist maths. So feel free to access them even if I'm not your teacher. Okay, best of luck.